Exercise Day 8. Testing of hypothesis. Purpose 1. In each cell of the Z correlation matrix, we can see correlation coefficients. Interpretation of R question type. So the correlation matrix is here. Interpretations of R is between -1 and +1. If R is 0, there is no relationship between the two variables considered. If +1 or -1, then the two variables are in a perfect relationship. Perfect means if we know the value of x, then we can know the value of y exactly through a linear equation. So 0, no relationship, +1 perfect, -1 perfect. Therefore, if the correlation coefficient value R is close to 0, then there is a weak relationship. The closer, the weaker. And far from 0, near to +1 or -1, then stronger and stronger. Stronger correlation means if we know the value of one variable, we can estimate the value of another variable quite adequately, quite precisely. Geometrically, perfect correlation keeps scatter points on a line, xy points of the data set, on a straight line, +1 or -1, straight line relationship. So not quite straight, but if very close to a straight line shape, then you will get 0.9, 0.8 like this. And if the shape of the cloud of points is far from a straight line shape, then the value of R becomes closer and closer to 0, weak relationship. In that situation, if we know the value of one variable, we cannot predict another variable quite precisely, only loosely. Okay, next one, p-value. P-value is the probability value of the test statistic. In the output, p-values are given nearby the correlated test statistic. So in this lesson, you will study this hypothesis. HO rho is 0. What is rho? Rho is the correlation value for population. If we know the data of the whole population, we can compute rho value exactly. We will know. But we don't know all data of the population, therefore we take a sample and we compute it, the value only from the data. Therefore, this is the value coming from the sample data. We denote it by R. We know the value of R. We don't know the value of rho. Therefore, we are testing about rho. What is important is rho will be 0 or not 0. If rho is 0, then there is no relationship between x and y. If rho is not 0, there is a linear relationship between x and y. So so HO, HA are written like this. This is not HO, HA, alternative hypothesis. Okay, this test uses T-table, T statistic. And this test is two-tilt test. Rho may be on the left of 0, rho may be on the right of 0. Therefore, in the T-table stretch, T-curve stretch, you have to cut. mark 2 points equally distant from 0 to the right and left. One is a positive critical value, another is negative critical value. Farther than critical values are called rejection regions. T values farther than critical value from 0 are forming rejection regions. Two rejection regions on the right and on the left. Okay, in reading T-table needs degrees of freedom. Your degrees of freedom is m minus 2. There are two variables we consider, therefore minus 2. And test statistic. Because you use T-table, you have to use T statistic. But your original statistic is R statistic. The value from the sample. If R is very far from 0, very big, or very big positive or negative, then this is stronger evidence for HA. To compare exactly, you have to transform R value to standard T value by this formula. You have to remember this formula when you see it. You change R to T, so you have to learn calculator work. You can also compute like this: R times square root of m minus 2 divided by square root of 1 minus R square. If you press in the calculator, you compute like this. In the calculator, it will look like this: R root m minus 2. You can enter number in place of m minus 2 and root sign, then open bracket 1 minus R square equal to. So after that, if the test statistic is in the rejection region, reject HO. That's it. Okay, here you have learned that in every cell there are two values. So one is R, another is P value. Okay, here P stands correlation coefficient given, and n is 20 pairs of data. How many variables? 10 variables. K is 10, you say. K is 10, n is 20. Okay, the question is interpret the correlation coefficient between x1 and x9. So row x1, column x9, this one negative 0.049, negative 0.049, very small. At most negative 1, so we see negative 0.5 is the middle. Now this is very close to 0, therefore very weak and negative. Therefore inverse relationship, negative relationship, weak. Therefore weak and negative, you should say weak, negative. Linear relationship. Here the values here. Okay, testing row 0, row not 0, critical value 2.1, positive 2.101, negative 2.101. You go to T-table and choose 2 tilde column, not 1 tilde column, 2 tildes. Where is alpha? 5% level, therefore alpha is 0.05. You must check alpha, 2 tilde alpha, 2 tilde alpha, because your test is 2 tilde test. 2 tilde test, 2 tilde alpha column. Degrees of freedom m minus 2, 20 minus 2, 18. You go and read, you will get this number. After the value of the test statistic is here, R statistic, you change to T by the given formula, R times, enter this value for R times square root of 18, m minus 2 divided by square root of 1 minus, and copy this one, R take square, equal to, and you will get this value negative 0.2, close to 0. not further than critical value, therefore not in the rejection region, not in the rejection region. Okay, but you can check b value also. B value is not smaller than alpha 0.05, very big. So if b value is smaller than alpha, reject. If b value is not smaller than alpha, not reject. Conclusion is about decision is about HO is not rejected. You write formally like this, and the conclusion must be about HA. HA is true or not, rho is not 0 or not. Rho is not 0 means there is a correlation. So there is correlation, no correlation. You write as a correlation. Significant means strong evidence. So now you get all answers.